So, in our first investigate, we spun around, rotated around, and we found the sun as our nose was pointing at the sun. And we figured out that we had to move counterclockwise to emulate the Earth's rotation. In the FYI, Earth's rotation, it says that ancestors must have observed the motions of the sun, stars, and planets across the sky each day and night, and they believed the entire universe was moving uniformly around us here on Earth. So, put yourself into their position. Thousands of years ago, you see everything going around. You see this really bright light in the sky, which is Jupiter, and you see it moving around. And then you see these shapes made up of a whole bunch of different stars, and they're also moving around, and then they come back again the next day, and then they come back again. So I hope you can put yourself in that position and understand that that is how humans once thought we were at the center of the entire universe, everything spinning around us. Obviously, it's not the case, and we don't matter that much. With the advent of telescopes, astronomers were able to observe that other planets and moons rotate or spin. This leads them to understand that Earth also rotates. Each planet and moon spins around on its axis. This dotted yellow line here is the axis. That's an imaginary straight line through the center, which the body rotates. The places where the axis meets the planet's surface are called the poles, or geographic poles. There's geographic poles and magnetic poles. Different places on the globe, but for us, North Pole, we're Santa Claus lives. A planet's axis also determines its equator. The equator is this imaginary circle, this red line on Earth, or pink or purple or fuchsia, this red line right through here. The equator is an imaginary circle around the planet at a distance halfway between the poles. As different parts of the planet turn toward and away from the sun, day becomes night and night becomes day. When our nose is pointing towards the sun, then it's day. When it's pointing exactly away, then it's night. Because Earth rotates towards the east, the sun rises on the east coast of the United States before it rises on the west coast. The Earth's rotation is also the reason why the sun appears to move across the sky, and why the stars and planets appear to rise and set each night. The rotational rate of the planet determines the length of the day. For example, Earth rotates on its axis about once every 24 hours. Some planets, such as Jupiter, have shorter periods of rotation, and some, like Mercury, have longer periods of rotation. So that's pretty much it for this first little activity. Very brief. Our daily motion can be explained by the rotation of the celestial sphere. We're going to learn about what the celestial sphere is in the next activity. Now complete those checking in questions on your FYI. And now go back and do the pause and reflect questions. I know it's kind of jumping around, but that's why we're building this notebook. See you next time.